In 2006, the Department of Environmental Quality and US EPA completed this study. It's Lake Helena Framework Water Quality Restoration Plan. In large part, it dealt with the nutrient issue, nutrients being nitrogen and phosphorus.
Nitrogen and phosphorus are two elements essential to the basic cellular makeup of all living organisms. In one form or another, they have long been used as a key ingredient in agricultural fertilizer. In biological terms, nitrogen and phosphorus serve as environmental limiting factors. Their presence, or lack thereof, determines the growth potential of the life forms within a particular ecosystem. On land, fertilizing with those two elements results in less harvests, but in aquatic environments like lakes, streams, and slow-moving rivers, the introduction of excess nitrogen and phosphorus can trigger an explosion of algae and bacteria. Large populations of algae and bacteria can deplete the water body's supply of oxygen, reducing water clarity, killing off other aquatic life forms, and leading to a process called eutrophication, where the lake or stream slowly becomes a marsh or bog before eventually disappearing altogether. How do excessive amounts of nitrogen and phosphorus enter a waterway? The EPA has identified 5 primary sources: runoff from heavily fertilized land, runoff that passes through large quantities of animal waste, runoff from urban areas with no stormwater management, effluent from wastewater treatment facilities, and overflow from septic systems.
All sewage comes in here. Anything comes out of your house, restaurant, hotels, whatever. Also septic tanks. In summertime we can see 12, 16 septic trucks a day dumping full loads. The whole purpose of really the whole wastewater plant is to provide the perfect environment, as perfect as we can provide, for the bacteria to do the work for us. This is mechanical treatment. It's just using gravity again that comes in through the center there and allows the heavy stuff to settle to the bottom. That sweep that's turning around, it goes all the way to the bottom of the tank. It pushes all the sludge to the center. It's cone shaped in the bottom, and we pump that sludge from this tank to these. There's another digester on the other side to these 2 digesters. And this sludge, after 45 days, in the wintertime we compost it out at the county landfill. In the summertime we inject in the farmer's fields. It's loaded with nutrients, so it's he wishes we could give him more than we do. I mean, we give him all that we got, and he loves it. It saves him a lot of money in fertilizer. If he could take our effluent, the water, he would. This is our bioreactor. This is where the bacteria does the work. Through this process, I won't get into all the biology, but through this process of going anoxic cells to aerobic cells, this creates the perfect environment for the microbes that remove ammonia to do their job. Along with removing ammonia, we still do this does the BOD and TSS removal, all that stuff. So from here, the flow goes to these 3 clarifiers, and what's going over the weir here is what ends up going through our disinfection. We use these are ultraviolet disinfection modules, and basically ultraviolet light, what it does is it sterilizes the bacteria so they can't reproduce. And we used to have chlorine. Ultraviolet light, much safer, works great. So this is what's going to Prickly Pear Creek.
Lewis and Clark County got a grant through the US EPA to take a look at Prickly Pear Creek, and specifically Prickly Pear Creek, to see what could be done to reduce nutrients and the nutrient problem in there. Municipal component is here. If we meet our reduction goals alone, the problem is still this big, and the goal is here. So, like I say, you know, the city can help, but we can't solve the problem alone. The nutrient issue isn't just a Montana issue. It's a nationwide problem that the EPA is targeting new clean water regulations towards. And Montana is out there leading the pack on some of these regulations in regards to nutrients. To achieve the goals that they're trying to achieve relative to water quality will require a very severe reduction in nutrient loads to our watersheds. And those levels are so low that for municipalities, there hasn't been conventional treatment technologies that have been developed that handle that economically. And we think there's other alternatives too to reducing that nutrient load, such as transferring septic systems to municipal treatment would be one way, because septic systems can only treat the nutrients, nitrogen at least, down to about 50 parts per million, that at best case, whereas we can get it down to about 5. And they looked at the potential of the city of Helena moving their discharge to the Helena Valley Irrigation Canal, which is not an uncommon thing for wastewater discharges to be used for irrigation purposes.
Helena Valley irrigation ditch it's just a mode to transport our effluent to be used for irrigating cropland and stuff. Plus, with the flow going through that canal, we would only be 1/50th to 1/100th of the total volume going through that canal. In the summer months, prickly pear is irrigated so much that a lot of times we are the creek. So they're already using our water to irrigate in the valley.
The potential for reducing at least Helena's component of the nutrient problem is substantial. I don't see it as a city versus county issue. I see it as an issue, and it's going to take both of us to solve the problem, and not one of us can do it. And so that's where the problem is. I mean, we can take care of our end, but it's not going to solve the problem.